s equal to ut plus r fifty squared. Now what do we do? Now we're going to assume that the first time, time 1, we're going to assume that time 1 is n minus 1 second. That's the first thing we're going to assume. We assume that time 1 is this, then time 2 is just n seconds. So we're going to be getting the distance traveled along time 1 and distance traveled in time 2. So don't forget, for distance, for example, distance traveled in the 4th second is, you're going to get the distance traveled after 3 seconds and the distance traveled after 4 seconds, then get the difference. So quickly, we're going to get the distance first traveled in the time 1. So we're going to be using this. Don't forget this, so we're going to do this. Distance is a formula. Distance traveled in the n time is equals to distance traveled in time 2 minus distance traveled in time 1. We're going to be using this. So we're going to be using. So let's get the distance traveled first in time 1. So distance traveled in time 1. Let's see. Now don't forget that here they have a common initial velocity. Whatever the initial velocity is, if the body starts from rest, initial velocity will be 0. So whatever the initial velocity is, it's going to be the same thing for the two, for the two various distances you're going to get for the two various, time. So the first st1, which is distance for time 1, is going to be initial velocity. Now don't forget the time. The time 1 is stated up there, n minus 1 second. So what's the time 1? The time 1 here, which is the first time, is n minus 1 second plus 1 over 2 times acceleration. Acceleration is acceleration along x-axis. Everything is along x-axis. Then times time, that's the same time. Time is going to be, that's time 1, n minus 1 raised power 2. So distance for body for time 1 is u, n minus 1. Don't forget that the n is, the n represents, the n minus 1 represents the first time, and the n also represents the main time you're talking about, the 4th second, the 5th, whatever kind of second. So u bracket n minus 1 plus 1 over 2 times acceleration, n minus 1 raised power 2. So what do we do next? We're trying to get time 1. So that will be un. I open up this minus u plus a over 2, n minus 1 raised to power 2. So there's the first distance traveled in the time 1. It's already boxed up. So the next thing you're going to do now, you're going to get the distance traveled by the body in time 2. The distance traveled by the body in time 2. So that's what we're going to do. So the same thing, distance traveled by the body in time 2. Don't forget, they have the same initial velocity. They have the same initial velocity. They have the same acceleration, but the time is different. So how do we do that? So this distance traveled by the body in time 2, initial velocity remains